Hi everyone, hope you are preparing well. So, I am going to discuss all the questions from CPET 2020. First question is, which one of the following compounds give a primary alcohol upon reaction with methyl magnesium bromide? And the options are ethylene oxide, propylene oxide, ethyl format and carbon dioxide. Okay. So, if you draw the structure, it will be like this. We have one epoxide, another one is also epoxide, and we have ester, that is ethyl format, and carbon dioxide. So, you know, any alkyl magnesium bromide when reacts with ethylene oxide, it forms primary alcohol. Okay, and we have a methyl magnesium bromide, Grignard's reagent. So, it will react with obviously ethylene oxide and they will form an adduct which upon acid hydrolysis will form primary alcohol, that is CH3 CH2 CH2OH, propanol. Okay, propyl alcohol. So, the correct option will be A. Second one is, which one of the following statement is correct for alkyl halide? Alkyl halide will always show SN1 mechanism? No. In a unimolecular reaction, increasing the temperature doesn't favor even mechanism. It is also not correct. Even mechanism is favored over SN1 mechanism for primary alkyl halide. No. Even mechanism is favored over SN1 mechanism for tertiary alkyl halide. Okay. So, the correct option will be D. Okay. Next one is, aryl halides are less reactive towards nucleophilic substitution reactions as compared to alkyl halides. This is due to, first option is formation of less stable carbon ion, second is the inductive effect, third is longer carbon halogen bond, and the fourth one is sp2 hybrid carbon attached to the halogen. So, if you write the structure of any aryl halide and any alkyl halide, you can clearly see that in case of aryl halide, we have one sp2 hybridized carbon atom. Okay. Whereas, in case of alkyl halide, we have one sp3 carbon atom, sp3 hybridized carbon atom. So, you know, more the percentage of S character, more will be its electronegativity, and in case of aryl halide, we have sp2 hybridized carbon atom, that means 33.33% of S character, but here we have 25% S character. So, here the electronegativity of this carbon will be more as compared to this carbon. Okay. So, more the electronegativity, that means more the tendency to attract the shared pair of electron. Moreover, if you draw the resonating structure of this molecule, then you can see that this carbon halogen bond will get partial double bond character. That means this bond is getting stronger, cleavage of X is becoming more difficult. So, here bond strength is more and bond length is less. That is why here cleavage of X, that means nucleophilic substitution reaction, is difficult. So, you can say sp2 hybrid carbon attached to the halogen is responsible for difficult nucleophilic substitution reaction. And also, if you cleave this X atom and will get one phenyl cation, that is very unstable. So, it will not favor and it will not show nucleophilic substitution reaction. So, the next question is, identify the reactant X in the following reaction sequence. So, you are given with a series of reaction and we have to find out X. Okay. So, the options are benzoic acid, salicylic acid, aniline and phenol. So, if you draw the structures of all these compounds, then this is our benzoic acid, this is salicylic acid, and this is our aniline and phenol. Okay. So, the correct option will be aniline, right. So, if you treat aniline with different types of reagent, then you can ultimately get 1,3,5 tribromobenzene. So, the right option will be aniline. C. Which one of the following structures represent the major product in the following reaction? We have one reactant and you are given with HBr. Okay, and the options are these. So, if you treat this reactant with H plus is from HBr, then this OH will abstract this proton and that will be removed as water molecule. Okay, so we'll get one carbocation here, but 1,2 hydrogen shift will takes place, and here we have the carbocation. So now Br minus can attack from both the side. Okay, from both the side it can attack, and we have these two products. So the correct option will be B. Next one is, if 2-methyl butane will be subjected to monobromination, then how many isomers with will it form? Okay, and the options are 4, 6, 5, 2. So you are given with 2-methyl butane. Write the structure, then it is our 2-methyl butane. We have 4 carbon atom, and upon bromination, monobromination, that means one bromine will be added. So bromine will be added to this carbon atom, this carbon atom, this carbon atom, and these two carbon atoms are similar. So it will be added to this carbon atom, like so we have 4 products, 4 isomers, that is 1 bromo 3-methyl butane, 2 bromo 3-methyl butane, 3 bromo 3-methyl butane, and 1 bromo 2-methyl butane. So the correct option will be A, that is 4. We will get 4 isomers. Next one is, calculate lambda max value for the following compound using Woodward-Fisher rule. So it is from UV visible spectroscopy. See, we are given with one carbonyl compound. So we will take the base value for alpha beta unsaturated carbonyl compound, because we have one double bond at alpha position. Okay, alpha and beta. So this carbonyl group is on our 6-member group. So we will take the base value for 6-member alpha beta unsaturated carbonyl compound, that is 215 nanometer. We have one ring residue at beta carbon, one ring residue at delta carbon. So we will add 12 nanometer and 18 nanometer respectively, and one double bond is also extending conjugation. So we will add up 30 nanometer for this, and one exocyclic double bond, so 5 nanometer. So if you sum up, then it will come out to be 280 nanometer, and we have 279 nanometer in our option. So the option B will be our correct option. Next one is, which one of the following compounds with molecular formula C4H9NO2, so 1H NMR peaks at this ppm. Okay, delta value we are given with 1, 2, 3, 4, 4 delta values in ppm, and we have 4 options. So if you observe, then the correct option will be option number C, that is CH3NHCOOCH2CH3. Okay, you can also check out. So CH3NHCOOCH2CH3. So here 3 hydrogen, and it will be doublet, del value will be 2.80 ppm. This is 1 hydrogen broad spectrum, and we have del value in 5.30 ppm. Here another peak, that is 2 hydrogen quartet, it is 4.10 ppm, and 3 hydrogen triplet 1.20 ppm. Okay, it is at 1.20 ppm. So the option will be C. The sodium extract of organic compound develops a blood red color on treatment with FeCl3 solution. The ion responsible for this color test is Cn minus, NCS minus, CNO minus, or H2 minus. Okay. So this question is basically from your Lasagne test, which is for our element detection. Okay, element detection in organic compound. So Lasagne test, or in Lasagne test we make Lasagne's filtered or sodium extract. Okay, we make sodium extract or Lasagne filtrate. So if your compound is containing carbon, nitrogen, and sulfur, it will react with sodium and it will form NaSCN. Okay, and upon treatment with FeCl3, so this Fe3 plus ion from FeCl3 will react with NaSCN, and they will form FeSCN whole 3, that is ferricyanide, which is responsible for the blood red color. Okay, so the option B will be the correct option, that is thiocyanate ion, NCS minus. Next is, which one of the following statement is correct regarding the following reaction? Okay, we are given with one reactant and reagent, and you have to find out the product, and you have to check out these options. So if you complete the reaction, see, you have one tertiary butoxide ion, that is base. Okay, base is present, then that means E2 mechanism will be favored, and here base will attack to the beta hydrogen. This is our alpha carbon and this is our beta carbon. So, base will attack to the beta hydrogen and it will remove the hydrogen atom. Okay. So, here one double bond will be formed, that is pi bond, and our product is Hofmann's exocyclic alkene. Okay, this beta hydrogen will be removed instead of this. Okay, and the product will be Hofmann's exocyclic alkene, that means less substituted alkene will be favored. So, the correct option will be D. Major product is exocyclic alkene formed according to the Hofmann. Next one is suggest the product of the following reaction. We are given with this reactant and reagent NaOCH3. Okay, sodium methoxide. So, see, from sodium methoxide, methoxide ion will attack to this carbonyl carbon and we have O minus ion, then it will extract one hydrogen atom and forming this product. So, option B will be the correct one. Which one of the following reaction is not an example of E1CB reaction? Okay, and we have 4 options. These are the 4 reactions. So, if you clearly see, then from option D we have tertiary butoxide ion. So, tertiary butoxide is not E1CB, instead it will follow E2 mechanism due to the presence of this bulky base. Okay, and the reaction will be like this. So, the option D will be correct one. Next is, what is the correct statement for the given reactions? We are given with substituted cyclohexane, CH3COO minus and CH3COOH. We have to find out X and Y. So, see, in the first option, which substitutions are at anti position. This is our anti-diastereomer. So, upon treatment with ACOH, we are getting again anti product. Okay. So, here retention of configuration takes place. On the other hand, this is our syn diastereomer. Substitutions are at syn position. Okay. So, upon treatment with ACOH, we are getting again anti product. The reason is, here one ring flipping takes place and that is why we are getting such kind of product. So, we can say that both the reactants are giving same product. Option B will be the right one. Okay. And it follows Neighboring group participation reaction mechanism. You can follow the Clyden book of 2nd edition, chapter number 36, 932 page. Okay. I have also added the screenshots, you can check it out, this one and this one. Next is, what is the correct order of nucleophilicity in the following options? We are given with 4 options. So, nucleophilicity. What do you mean by nucleophilicity? The ability to gain its extra electron pair. Okay. So, you know, if you compare the same central atom, higher electron density will increase the nucleophilicity. Obviously, if the atom has higher electron density, then it can donate its extra electron pair very easily. Okay. So, anion will be better nucleophile than a neutral atom. For example, CH3S minus is a better nucleophile than CH3SH. So, option C will be the right one. Okay. Question number 15. Which one of the following statements is true about the reaction given below? We are given with this reaction. Okay. See, we have to see the mechanism of this reaction. This is our reactant. Here we are given with NaOCH3. So, here this methoxide ion attacks this carbon atom. Why? Because this is electron rich species, bromine rich electron rich species. It has extra lone pair of electrons. So, this will attack, this nucleophile attack from the back side. Okay, back side this carbon atom, and here cleavage of this bond takes place. Again, oxygen atom attacks to this carbon atom to cleave bromine atom. Okay, to cleave this bond. So, we are getting this product. What happens here? SN2 mechanism takes place because both these steps takes place simultaneously in a concerted pathway. Okay. So, option A will be the right one. It proceeds via a concerted SN2 pathway, single step reaction. Concerted means single step reaction. Which one of the following substituents on the benzene ring is not a meta-directing group in an electrophilic substitution reaction? What is electrophilic substitution reaction? A substitution reaction where the attacking reagent is an electrophile. Electrophile means electron deficient species. So, obviously, it will attack to that position which is electron rich. We have some electron withdrawing group and electron donating group. Whenever some electron withdrawing group is attached to the benzene ring, it will withdraw electron from ortho and para position. Okay. So, ultimately the meta position will be electron rich and electrophile will attack to that meta position. Okay. So, electron withdrawing group is meta directing, but if you have electron donating group already present, then it will direct the electrophile to ortho and para position. Okay. Electron donating group is ortho and para directing. So, CF3 is electron withdrawing group. This is also electron withdrawing group at the ortho and para directing. This is also ortho and para directing, but bromine atom, bromine is electron donating group because it has some lone pair of electrons. So, it will be electron donating group means it will be ortho and para directing. It is not meta directing. Okay. Which one of the following alkanes exhibits optical activity? What is optical activity? The ability to rotate plane polarized light towards right or left. It can be dextrorotatory or levorotatory. So, a molecule to be optically active, it should possess at least one chiral carbon and it shouldn't possess any symmetry element. So, what is chiral carbon? A carbon that is attached to 4 different groups. Okay. So, all we have to do is write down the structure of all these compounds and we will check whether it possesses any chiral carbon or not. First one is neopentane, it is 4CH3 group. So, it is obviously not chiral carbon. And then isopentane, sorry, this one is isopentane. So, we have 2CH3 group and it is also not chiral carbon, it is not optically active. Then 3-methyl pentane, this is 3-methyl pentane. So, we have same CH2CH3 group, ethyl group on both the side. So, it is not chiral. But in option D, we have 3-methyl hexane and here 4 different groups are attached and it is optically active. Which will be the most appropriate reagent for the following transformation? We have one reaction, okay, and we have 4 different type of reagent. So, here one carbonyl group is converting into alkene. So, this is Wittig reaction, you know, and in Wittig reaction we take the help of ylide, triphenyl phosphorus ylide, okay, and it takes place via 4-membered cyclic intermediate and here cleavage of these 2 bond takes place and we get alkene. So, option B will be the right one. Which one of the following carbocations is the most stable? We have 4 different type of carbocations. See, in option D, we have one double bond and this double bond is next to the carbon containing positive charge. Okay. So, here resonance can take place and due to resonance we have 2 resonating structure and also there is 3 alpha hydrogen. This is alpha to the positive charge. So, we have 3 hyperconjugating structure also. So, due to hyperconjugation and resonance, this one is the right answer. This one is the most stable carbocation. Name the process associated with acylation of benzene. Friedel-Crafts reaction, Urge reaction, Urge-Wittig reaction, aldol reaction. The Friedel-Crafts reaction is 2 types, Friedel-Crafts alkylation and Friedel-Crafts acylation. So, in Friedel-Crafts acylation, acyl group CH3CO group is added in presence of anhydrous AlCl and it is added to the benzene or substituted benzene. Okay. So, Friedel-Crafts reaction is the right answer. Which one of the following statement is incorrect? First step in photochemistry is the excitation of electron. Yeah, it is correct. When a molecule of atom in the ground state S0 absorbs light, one electron is excited to the higher orbital level. Yeah, it is also correct. Photochemical reactions are caused by absorption of ultraviolet light only. No, because photochemical reaction can be caused by UV plus visible light. Okay, this is incorrect and it is possible for the excited state S1 to undergo spin inversion. Obviously, it is correct. So, option C will be the right one because photochemical reaction can be caused by UV and visible light. Next question is, arrange the following intermediates in the descending order of their stability. We have 4 type of carbocations. See, in option 1 we have OH group para to this carbocation. Okay. And OH group is electron donating group. It has plus M effect. So, it will donate its electron to CH2 plus. Okay. And here positive charge will decrease and it will become stable. So, this plus M effect enhances the stability. Whereas in option 2 we have minus I group, that is NH2, and plus M. So it will also donate its electron to CH2 plus and enhances the stability. In option 3 we have plus I group only, CH3 group, and in fourth option we have plus M and minus I group, that is chlorine. So if you compare option 1, 2 and 4, then we have plus M group, that is OH, NH2 and Cl. All these groups are plus M group. But if you compare them, then nitrogen has less electronegativity than oxygen and chlorine. So here lone pair of electron donation can take place very easy. So that is the reason why our option 2 is the most stable carbocation. So order will be 2, then 1, then 3, then option D will be the right one. The IUPAC name of the following compound is. To the structure of this compound, then you can see here one double bond and one triple bond. Both these bonds are there, and you know the priority order of double bond is more than that of the triple bond. That is why we will number them from left to right. 1, 2, 3, 4, 5, 6, 7. At fourth position we have one chlorine atom, and at fifth position we have bromine atom. We have to arrange them in alphabetical order. So the name will be 5-bromo 4-chloro hept, because we have 7 carbon atoms hept, 1 in 6YN. Okay. Which type of macromolecules carries out catalysis in biological system? So in biological system we have the catalyst that is known as enzyme. Biological catalyst is enzyme. Enzymes are made up of proteins. Okay. So option A will be the right one. Alright. Question number 25. A nucleotide is constituted from which of the following units? What do you mean by nucleotides? Whenever nitrogenous base, pentose sugar and inorganic phosphate, all these compounds will together constitute nucleotide. Okay. And you know nitrogenous base are of two types, purines and pyrimidines. Purines are adenine and guanine. Pyrimidines are uracil, thiamine, cytosine. In RNA we have uracil instead of thiamine, but in DNA we have adenine, guanine, thiamine and cytosine. Pentose sugars are of two types, like ribose and 2-deoxyribose, and this one is present in DNA, and this is our inorganic phosphate. Moreover, you have to remember that nitrogenous base and pentose sugar, these two are collectively known as nucleoside, whereas these three components whenever together present they are known as nucleotide. Okay. Base, sugar and phosphate. The change in free energy of a reaction at equilibrium is negative, positive, zero or difficult to predict. So from thermodynamics, you know the change in free energy of a system is denoted by delta G. Okay. When delta G equal to 0, that is equilibrium system or at equilibrium reaction. Okay. Delta is greater than 0, that is positive value, it is for non-spontaneous reaction. Okay. And delta is less than 0, that is negative value for spontaneous reaction. So the change in free energy of a reaction at equilibrium is 0, because it is asking about equilibrium. Next one is, if doubling the initial concentration of a reactant doubles the half-life period, of the reaction, then order of reaction is what? 3, 2, 1 or 0. See, these are order of reaction, and this is equation for T half, that is half life period, and we have some conclusion. For zero order reaction, T half equal to A by 2k, A by 2k. Okay, and we can conclude that T half is directly proportional to the A power of 1, A to the power of 1. So you can say that when A equal to 2A, A is initial concentration. Okay, and the question is asking about when A is 2A. Okay, we are doubling the concentration of initial concentration. So obviously T half will be 2 T half. So the right option will be D, that is zero order reaction. And this is the expression for first order reaction, second order reaction, and this is nth order reaction. Okay, and for nth order reaction, you can conclude that T half is inversely proportional to the A power of n minus 1, and this is not valid for first order reaction. Question number 28. If psi is the wave function, then what is the probability of finding an electron in given region within the atom? So this is from basics of quantum chemistry, or you can say is from atomic structure. And you know, the probability of finding an electron within the atom is denoted by psi square. Psi square. 1 coulomb is the charge of 1 mole of electron. 1 by 96500 mole of electron, 96500 mole of electron, or none of these. You know, the SI unit of charge is coulomb. Okay, and charge of 1 electron is 1.66 into 10 to the minus 19 coulomb. So 1 mole of electron will be, obviously, you know that from Avogadro's law, 1 mole of electron is equal to 6.022 into 10 to the 23 number of electron. Okay, so 6.022 into 10 to the 23 into 1.66 into 10 to the minus 19 coulomb will be equal to 96500 coulomb, which is known as 1 Faraday. Okay, so you can say that 96500 coulomb is equal to 1 mole of electron. So 1 coulomb will be 1 divided by 96500 mole of electron. Option B will be the correct one. The pressure correction in van der Waals equation is due to what? Attractive force of molecules towards the interior, attractive force of the molecules towards the boundary wall, repulsive force of the molecules towards the interior, or repulsive force of the molecule towards the boundary wall. So the correct option will be option A, that is attractive force of molecule towards the interior. And van der Waals equation for real gas is P plus an square by V square into V minus Nb equal to nRT, and this equation is valid for n moles of gas. The relationship between Cp and Cv for n mole of ideal gas is what? You know, Cp is specific heat capacity at constant pressure, and Cv is specific heat capacity at constant volume. And from thermodynamics, you know that Cp minus Cv equal to Nr for n moles of ideal gas. Okay, so Cp will be what? Cp will be equal to Cv plus Nr. Option B will be the right one. Question number 32. The relationship between the contact angle and wettability of a liquid is what? Proportional, inversely proportional, independent, or none of these. So the contact angle varies inversely with wettability. So if you have small contact angle, that is less than 90 degree, then high wettability will be there. If you have large contact angle, then low wettability. So the correct option, inversely proportional. What will be the amount of work done if 10 moles of an ideal monoatomic gas at 10 atmospheric pressure and 27 degrees centigrade temperature is allowed to expand isothermally against a constant pressure of 1 atm? Minus 5.36 kilocalorie, 5.36 kilocalorie, minus 4.32 kilocalorie, or 4.32 kilocalorie. See, for isothermal expansion, we have W equal to minus 2.303 RT log P1 upon P2. Okay. And here N equal to 10 moles is given, and P1 is 10 atmospheric pressure, P2 is 1 atmospheric pressure. Temperature is given 27 degrees Celsius. If you convert it into Kelvin, then it will be 300 Kelvin. So you have to just substitute all the values, and it will be equal to minus 5744.1426 calorie, and you have to convert it into kilocalorie. It will be minus 5.744 kilocalorie, which is roughly equal to minus 5.36 kilo. Question number 34. Which of the following is not applicable to absorption phenomena? Langmuir equation, PET equation, Anderson equation, or Freundlich equation? See, this is from surface chemistry, and you know Langmuir equation, PET equation, and Freundlich equation, all these are related to absorption phenomena. But Henderson equation is for the calculation of pH of buffer solution. Okay, pH equal to pKa plus log salt by weak acid, and pOH equal to pKb plus log salt by weak base. Question number 35. Which one of the following terms is not associated with phase rule? Okay, this is from phase equilibrium. Triple point, eutectic point, critical point, or plate point. You know, triple point, eutectic point, and plate point, all these are associated with phase equilibrium, but critical point is not associated with phase rule. Which of the following is an intensive property? So from thermodynamics, you know, properties are of two types: intensive property and extensive property. Intensive property means the properties which depend only on types of matter in a sample and not the amount. Okay, and this property is fixed for a particular component. So specific heat is an intensive property. What is the degree of freedom of 0.1 an aqueous solution of NaCl? 3, 2, 0 or 1. See, here 0.1 an aqueous solution is given. That means it is unsaturated one, so phase will be 1, because you cannot distinguish NaCl from NaCl solution. Okay, NaCl crystal you cannot distinguish, and component is 2, obviously NaCl and water. So from phase rule, you know that degree of freedom equal to F equal to C minus P plus 2. So 2 minus 1 plus 2, 4 minus 1. So the degrees of freedom will be 3. Okay. What is the ionic strength of 0.2 m Na2H PO4? 0.4 m, 0.6 m, 0.5 m, or 0.8 m? See, here Na2H PO4 is given. So it will dissociate like 2 Na plus H PO4 2 minus, and we have the formula I equal to ionic strength I equal to half summation of CiZi square. C is the concentration and Z is the charge of ion. So we have two kinds of ion. So the formula will be half into C1Z1 square plus C2Z2 square. Concentration is 0.2, that is a 0.2 into, we have two number of Na plus, so 2 into 1 square plus 0.2, we have 1 HPO4 2 minus n, that is why 1 into charge is minus 2, that is why minus 2 square. So it will be equal to half into 0.4 plus 0.8, 1 by 2 divided by 2 equal to 0.6. Okay, option C is the right answer. Which of the following is not the rate expression for a reaction A plus 2B giving rise to 3P? Okay. So whenever you have to write rate of reaction in terms of reactant, then you have to put one negative sign, because concentration of reactant decreases. Okay, over the time concentration of reactant decreases and concentration of product increases. That is why we don't have to put any negative sign, we'll just sign positive sign to the product. Okay. So for this reaction A plus 2B giving rise to 3P, rate of the reaction in terms of A will be minus dA by dt, or in terms of B it will be minus 1 by 2 dB by dt. Why this 1 by 2 is written? Because we have stoichiometry coefficient 2 over here, so that is why minus 1 by 2 dB by dt, and here coefficient is 3, that is why 1 by 3 dP by dt. If you see the options, then in option C, the plus dA by dt, not the rate expression. Okay. At equilibrium, the process of adsorption involves delta H is greater than 0, delta S equal to T delta S, delta H is greater than T delta S, or delta H is less than T delta S. You know, for equilibrium process, delta G or change in Gibbs free energy is equal to 0. So, delta G equal to delta H minus T delta S. So, this from thermodynamics. And for delta G equal to 0, it will be like delta H minus T delta S equal to 0. So, delta H equal to 2 T delta S. Option B is the right answer. Question number 41. If molecule A absorbs light energy around 630 nanometer, the color of the solution will be what? Red, blue, green, yellow. See, if a solution or if a compound is absorbing some light, then it will show its complementary color of absorbed light. Okay, and you know, visible range is from 400 to 750 nanometer, and it includes Viv gear, that is 6 color. So we have to divide this difference by 6. 350 divided by 6, which is roughly equal to 58.33. Okay, so now what we'll do, will categorize this Viv gear into 6 parts. Okay, and the question is asking about 630 nanometer. Okay, compound is absorbing around 630 nanometer. So it will absorb somewhere around this yellow, orange, green. Okay, so complementary color will be here, and the option will be right option will show blue color. Okay, the half shell A plus electron giving rise to A minus has a large negative reduction potential. The consequence will be what? A is readily reduced, A is readily oxidized, or A minus is readily reduced, or A minus is readily oxidized. See, here we have reaction, we have the reaction A plus electron. That means A is gaining one electron and it is becoming A minus. Okay. So this process is nothing but our reduction, and you know, higher the value of E naught value, okay, higher the value of E naught value, reduction can take place easily. That means gain of electron, and lower value of E naught indicates oxidation. That means loss of electron. Here we have large negative reduction potential. Negative reduction potential, that means A to A minus is difficult because oxidation is easy. Okay, that means oxidation of A minus to A takes place easily. So option D is right answer. A minus is readily oxidized. Okay. Question number 43. At the end point of acid base titration involving a strong acid and a strong base, using an appropriate indicator, the pH of the solution will be what? Slightly alkaline, slightly acidic, neutral, or strongly alkaline. See, we have strong acid and strong base. That means higher concentration of H plus, because strong acid will release H plus ion concentration, and strong base, that means high concentration of OH minus. So this solution will be neutralized and we have neutral solution. Acting to transition state theory for a bimolecular reaction, the activated complex has what? No vibrational degrees of freedom. Not true. Vibrational degrees of freedom, but they never participate in product formation. This is also not true. One high frequency vibration that leads to product formation. High frequency vibration, no, it is not true. One low frequency vibration that leads to product formation, yes, is correct. Okay. Question number 45. The unit of molar extinction coefficient is what? Molar extinction coefficient is from your Lambert-Beer's law. So from that law we have A equal to epsilon CL. What is A? A is the absorbance, such formula log I net by I or log 1 by T. T is the transmitter. Okay. Epsilon is our molar extinction coefficient, C is molar concentration, and L is path length. We have to calculate the unit of epsilon. So unit of A will be 1 because absorbance is unitless. and concentration is mole per liter, and length, path length is centimeter. So it will be liter per mole per centimeter. Okay. Question number 46. Which of the following statements is correct? Hydrogen and helium are isotopes. Potassium and calcium are isotone. Carbon and nitrogen are isotopes, or fluorine and sodium are isobars. So we have to know what is isotope, what is isobar, and what is isotope. Isotopes mean two elements having same atomic number but different atomic masses. Okay, and atomic number means number of proton, so they have same number of proton. Okay, and atomic mass means number of proton plus number of neutron. Isobar means same atomic masses but different atomic number, that means number of proton and neutron obviously both are different. Isotone means same number of neutrons but their masses are different. Okay, so in these options we have hydrogen and helium, okay, carbon and nitrogen, potassium, calcium, and fluorine and sodium. So all we have to do is to calculate number of proton, number of neutron, and mass number. We'll add both this number of proton and neutron and we'll calculate mass number. Okay, so you can see for potassium and calcium the number of neutrons are same, that means these are isotone. Okay, option C will be right one. Potassium and calcium are isotone. Alright, question number 47. A molecule is Raman active if the molecule is polarizable, the molecule is paramagnetic, the molecule contains non-bonding electron, or the molecule contains center of symmetry. See, if a molecule is Raman active, then it must involve a change in the polarizability. Okay, and to be iron active, there should be a change in dipole moment. And what is mutual exclusion principle? For centrosymmetric molecule, Raman active modes are iron inactive and iron active modes are Raman inactive. Okay, this is mutual exclusion principle. So option A will be the right one. The molecule is polarizable for Raman active. Next one is cathode rays are deflected towards positive electrode, negative electrode, both A and B, or none of these. See, cathode rays are negative in charge, so they will deflect toward positive electrodes, and positive rays, that is anode rays, will be deflected towards positive negative electrode. Okay, so option A will be the right one. Cathode rays are deflected towards positive electrode, which is not a renewable energy. Solar energy, wind energy, tidal energy, or LPG. You know, LPG is the non-renewable source of energy. After bubbling air through pure water, which is pH equal to 7.0, its pH decreased. Which of the following is responsible for the pH change? Nitrogen, carbon dioxide, hydrogen, or oxygen? See, bubbling air, which is from our mouth, contains carbon dioxide. Okay, and this carbon dioxide will react with water forming carbonic acid, which has pH less than 7, and it is acidic in nature. So this carbon dioxide is responsible for the pH change. Which of the following is the correct order with respect to their relative stabilities? O2 plus, O2, O2 minus, and O2 minus. So all we have to do is draw MO diagram, molecular orbital diagram. The molecular orbital diagram for oxygen molecule, atomic orbital, and here also it is atomic orbital, and in between we have molecular orbital. Okay, and we have to write the MO configuration for O2, O2 plus, O2 minus, and O2 minus. I have written here, and then we will calculate bond order. The formula of bond order is half into Nb minus Na, number of bonding electrons minus number of anti-bonding electrons. So we will calculate Nb and Na and calculate bond order. For O2 bond order is 2, for O2 plus bond order is 2.5, for O2 minus it is 1.5, and for O2 minus it is 1. and you know, higher the bond order, higher its stability. Okay. So from this value you can conclude that O2 plus, which is highest bond order value, is the most stable one, and then O2, then O2 minus, and then O2 2 minus. Question number 52. According to Bohr's theory, the angular momentum of an electron, the fifth orbit is what? Okay, and you know Bohr's formula for angular momentum is mvr equal to n into h by 2 pi. It is the integral multiple of h by 2 pi. So we are calculating for fifth orbit, so n will be equal to 5 by 2 h by pi, and 5 by 2 is nothing but 2.5 h by pi. Option D is the right one. Then question number 53. In a crystal lattice, the Madelung constant depends on what? Ionic radius of cation, ionic radius of the anion, nature of the crystal system, or ionic radius of both cation and anion. For crystal lattice, potential energy, you know the formula of potential energy, minus A into Z square divided by R plus V by R to the power n, and we have lattice energy formula, lattice energy U naught equal to N into Z square E square divided by R naught 1 by N minus 1. This N is Avogadro's number, and A is Madelung constant, okay, and this equation is bond length equation. So this Madelung constant A depends on the geometrical arrangement of the ions in the crystal. So option C will be the right one. Madelung constant depends on nature of the crystals. Question number 54. Which of the following is the correct order of ionic radius? For sodium plus, Mg2 plus, Al3 plus, and Si4 plus, you have to calculate the radius. So we'll calculate number of electrons for all these ions, okay, and it will be 10. All these ions are having 10 number of electrons, okay, and number of proton will be, for sodium it is 11, for magnesium it is 12, and for aluminum it is 13, for silicon it is 14. And you know, more the number of proton, it will attract more firmly, it will attract more all the valence electrons. So attraction will be more and radius will be the smallest one. For silicon 4 plus, the radius will be small, and sodium it is the highest one. So Na plus is greater than Mg2 plus is greater than Al3 plus is greater than Si4 plus. Question number 55. Which one of the following pairs correspond to soft base pair? Okay, we have some hard acid and base, some borderline acid and bases, and some soft acids and bases. Okay, here is the list, and you can see SCN minus and H2O3 minus, O32 minus, all these ions, constitute soft base pair. Okay, and these are some characteristics of hard acid, hard base, soft base. Question number 56. The ionic compound which indicate pyrosilicate is what? SiO4 minus, SiO3 whole and 2 minus, Si3O9 6 minus, Si2O7 6 minus. What? You know, silicate is categorized into 4 categories: orthosilicate, pyrosilicate, chain silicate, and cyclic. Orthosilicate has formula SiO4 4 minus. There is one tetrahedral unit which contains silicon atom at the center and O minus. Pyrosilicate has formula Si2O7 6 minus. Okay, option D. In option D, we have Si2O7 6 minus. The structure is here, and here one oxygen is shared, or it forms breeze between two silicon atoms. Chain silicate is again divided into 2 categories, that is single chain and double chain. Cyclic silicate has formula SiO3 and 2N minus. The reaction of XCF6 with CSF produces a compound that undergoes decomposition after 50 degrees centigrade. The compound is what? Well, we have the reaction XCF6 plus CSF cesium fluoride, giving rise to CSXCF7 complex compound. Okay, so option C will be the right one. Question number 58. What is the precursors used for the synthesis of borage in Stokes process? In Stokes process, we use often B2H6 and NH3. They will react and form B3H6N3 benzene, boragine, and it is known as inorganic benzene. Okay, the formula of, or the structure of inorganic benzene is this. That's benzene like structure, that is why in like inorganic benzene. So the precursors are B2H6 and NH3. Okay. Which type of isomerism exists between these two complexes? Okay. Linkage isomerism, coordination isomerism, ionization isomerism, or coordination position isomerism. If you see these two compounds here, SO4 2 minus ion is outside the coordination sphere, and here Br minus is outside the coordination sphere. So these two compounds will exhibit ionization isomerism because they will produce different kinds of ions when they are dissolved, but the formula of these two compounds are same, so ionization isomerism. Question number 60. The primary and secondary valency of cobalt atom in this complex are 3 and 4, 1 and 6, 4 and 3, or 3 and 6. Primary valency means coordination number. That means number of atoms attached to the central metal atom. So here we have 4 NH3 group and 2 Cl2 group. So total 6 atoms are attached with coordination with cobalt. So that is why coordination number will be 6. Secondary valency indicate oxidation number. So we have to calculate the oxidation number of cobalt over here. So that is why it is X. NH3 is neutral ligand, so 0, and chlorine has minus 1 charge, so 2 into minus 1 and again minus 1. So it will be equal to 0 because it is a neutral complex. X minus 2 minus 1 equal to 0, X minus 3 equal to 0, X will be equal to plus 3. So oxidation number or secondary valency is plus 3. The rate of reversible hydration of carbon dioxide is accelerated by which of the following biomolecules? Carboxypeptidase, carbonic anhydrase, hemoglobin, or catalase. So rate of reversible hydration of carbon dioxide, that means CO2 and H2O, they will form HCO3 minus and H plus. So it is catalyzed by carbonic anhydrase. Among the following complexes, the one which shows zero crystal field stabilization energy is, see, in first option we have MnH2O whole 6 3 plus. We have to calculate crystal field stabilization energy. So it is a octahedral complex and it is high spin complex. That means water is weak field ligand. So oxidation state of manganese is plus 3 here, and in ground state manganese has 4s2 3d5 valence electronic configuration. Mn plus 3, it has 4s naught 3d4 configuration. Okay, so this 3d4 it will split like T2g3 and Eg1. So CFSE will be minus 0.4 into number of electrons in T2g and 0.6 into number of electrons in. So this will come out to be minus 0.6 dq deci quantity. So it is not the answer. Then option B. In option B we have FeH2O whole 6 3 plus. It is also octahedral complex and high spin. So oxidation state of iron is plus 3 again here, and in Fe plus 3 we have configuration electronic valence electronic DD5. So it will split like T2G3 and Eg2. So CFSE will be minus 0.4 into 3 plus 0.6 into 2, and it will come out to be 0 because minus 1.2 plus 1.2 equal to. So this is our answer. So we don't have to check for all each two compounds COH2 whole 6 2 plus and COH2 whole 6 3 plus. You can calculate the CFSE for each compound also. The complex eta 4 C8H8 MCO whole 3 follows 18 electron rule. Which of the following first row transition metal is present in it? Cobalt, iron, manganese or nickel. So we have this complex here eta 4 C8H8. So eta 4 means it has hapticity 4, that means it is donating 4 electrons, and carbonyl group, one carbonyl group donates 2 electrons, and we have 3 carbonyl groups. So here 2 into 3, that is total 6 electrons is donated by carbonyl group, and we have to calculate the valence electron of M. So here it is given that this complex follow 18 electron. Okay, this complex is following 18 electron. So 4 plus x plus 6 should be equal to 18, x plus 10 equal to 8, and x is equal to, that means the metal should contain 8 valence electron. Okay, so we have to check which metal contain 8 electrons in its valence shell. Cobalt contains 9 electrons in its valence shell, whereas iron contains 8 electrons in its valence shell. Manganese 7 and nickel contains 10 electrons valence shell. So the formula will be eta 4 C8 iron CO whole 3, because iron has 8 electrons. 1 mole of PtCl4 3 minus while reacting with 2 mole of NH3 gives what? So here in substitution reaction we have to follow the trans-directing strength. This is the order of trans-directing group. Okay. We have this compound PtCl4 2 minus, which is red in color. So we'll add 1 mole of NH3. So NH3 will be added to any of these. Let's say this is added to this position and one Cl will be removed. So again we will add one NH3 group. Now we have NH3 group and Cl group, and from this order we can see trans effect of Cl is greater than from NH3. So Cl will direct the incoming NH3 group to trans to it. Okay. So suppose this Cl will direct NH3 group trans to itself. So NH3 here, NH3 here, and Cl, and it is yellow in color. So the answer will be cis NH3 whole 2 Cl2. Next question is the reaction of NaCl and K2Cr2O7 in the presence of concentrated H2SO4 produces a vapor that turns aqueous solution of NaOH into yellow color. While treating this yellow color solution with aqueous lead acetate in the presence of excess CH3COOH, it gives yellow precipitate. Which of the following compounds does correspond to this vapor? Here we have NaCl and K2Cr2O7 in presence of concentrated H2SO4, it will produce a vapor, and this vapor upon passing with aqueous NaOH solution, it turns yellow color. Okay, and it is again when passing with lead acetate solution and excess CH3OH will produce yellow precipitation. So what is this vapor? When NaCl and potassium dichromate ion, and that is it is dichromate ion in presence of acid, concentrated acid from can get H plus ion, it will produce CrO2Cl2, that is chromyl chloride, with deep red in color. So correct answer will be this one, CrO2Cl2, chromyl chloride. Okay. The number of radial nodes present in 3s and 4d orbital respectively are 2 and 0, 0 and 2, 3 and 2, and 2 and 1. Number of radial nodes has a formula n minus L minus 1. N is principal quantum number and L is azimuthal quantum number. And for azimuthal quantum number, for S subcell, it has value 0, P has 0, has value 1, D has value 2, and F has value 3. Okay. So we have to calculate for 3s and 3d. For 3s, n equal to 3 and L equal to 0. So it will be 3 minus 0 minus 1 equal to 2, and for 3D n equal to 3, L equal to 2. So number of radial nodes will be minus 2, 1 equal to 0. Okay, 2 and 0. The brown ring complex compound is formulated as this. The oxidation state of iron in this compound is +3, +2, +1 or 0. So we have to calculate the oxidation number of iron. Okay. So it is taken as X, and water is neutral ligand, so 5 into 0. NO has here +1 charge and SO4 is -2. So all will be equal to 0. X plus 1 minus 2 equal to 0, X minus 1 equal to 0, and X equal to +1. Iron has +1 oxidation. Which of the following hybridization is present in ClF3 molecule? DsP3, sp3d, sp3d2 or sp3. ClF3 molecule. Here central atom is chlorine and it has valence cell configuration 3s2 3p5. You know, chlorine has ground state electronic configuration 3s2 3p5, but we need 3 unpaired electron because we have to make 3 chlorine F bond, but we have 1 non-paired electron. So excitation of electron 3p from 3p to 3d takes place. So chlorine excited state electronic configuration is 3s2 3p 3p5 3d1. Okay, sorry, 3s2 3p4 3d1. So here 1 3s orbital and 3 3p orbital, 1 3d orbital together will constitute sp3d hybridization. So free fluorine atom will donate its electron pair and they will make bond with this hybridized orbital. But we have again 2 lone pair of electron, and that is why the shape will be T shape. Okay, hybridization will be sp3d, and we know the lone pair repulsion is greater than from lone pair bond pair repulsion, which is greater than from bond pair repulsion. So the shape will be T shape and hybridization will be sp3. Which of the following sets of quantum number are correct for an electron present in 4f orbital? Okay. So for 4f orbital, n equal to 4 and azimuthal quantum number L equal to 3, and magnetic quantum number can have the value -2, -1, 0, +1 or +2. Whereas spin quantum number may have the value +12 or -12. So if you match these, then option C has n equal to 4, L equal to 3, M equal to +1 and S equal to +1, 1 by 2. Okay. Question number 70, which is the last one. Which of the following is the incorrect statement about Jesse salt? Jesse salt is diamagnetic. All the PTCl bond lengths in Jesse salt are equal. Oxidation state of platinum in Jesse salt is +2. Or carbon-carbon bond length of ethylene moiety in Jesse salt is longer than the free ethylene molecule. So this is our Jesse salt, which is the formula PTCl3C2H5. Okay, here all the PTCl bond length are not equal. Okay, so option B is the right one. So this is all about the questions of CPET 2020, and in the next part I will discuss all the questions of CPET 2021. Thank you so much for watching.